Hello and welcome back to the Arduino Python series, and this is the tutorial number 22. Today we are doing something really exciting. We will control two DC motors using our driver module, L298, and we want to add a real-time visualization using Matplotlib library. So when you press the start button, the first motor will ramp up smoothly. It's called soft start, and when the first motor reach the full speed, then the second motor again start softly, and again for the stop, when you press the stop, okay, then the first motor will start to ramp down, and after the first motor, then the second motor just start ramping down again. So, and this one called soft stop. So this project combines hardware control with Python's powerful data visualization libraries. By the end, you will understand how to use buttons as triggers, control two motors independently, and create live updating plots to monitor your system. Okay, let me just explain how we can set up our hardware. So we're gonna start with our buttons. So these are our buttons, the buttons that we're using. If you can see, these if you can see these lines, it means that these two legs, they are connected together, and these two lines, they are also connected together. So if when you want to install them on your breadboard, so how you can install them, it's just very easy. You hold it just like this, and put it on your breadboard, okay, and do the same thing with the second button, okay. And for the wiring, just don't forget to use 10k ohm resistor, okay. So one leg, from one leg, just connect it directly to the negative side of your breadboard, okay, with your resistor. So connect it directly with the resistor to the negative, and we're gonna do the same thing with the second button, okay. Just let me bring it here so it will be exactly yes. So I'm gonna connect it here, okay. All right. So, and from the opposite, from the same leg, just we have two buttons, the start and the stop button. So the start button, I'm gonna connect it to my pin number 2 of my Arduino board. So 0, 1, 2, I'm gonna connect it to pin number 2, and the stop button exactly from the same pin again, okay. But guys, let me just because I installed that in that pin, so I'm gonna install the yes, because it doesn't matter which pin, because I put this pin for this button. So I'm gonna just because I want both of them to be the same, that's why I change it, but it doesn't matter. So I'm gonna connect the stop button, I'm gonna connect it to pin number 4 on my Arduino board. So 2, 3, 4, this is the pin number 4 of my Arduino board, okay. And just one more thing, from the other leg, just connect the other leg to the positive of your breadboard. See, because I'm gonna connect the 5 volts of my Arduino board to the positive column and the GND to the negative column. So I'm gonna connect this to the positive, and I'm gonna do the same thing with the stop button. So I'm gonna connect this one to the positive as well. Okay, so the next step is to set up to just wire our L298 module. Just as I told you, we want to just change the speed. So if you can remember, in order to change the speed, we have to just remove these 2 jumper wires. It's very important, because if you do not remove these jumper wires, you cannot just control your speed, the speed of your motor, and you're gonna have a constant speed always. So very, very important, you have to remove these two jumper wires from the EN pins. Okay, so as you know, you already know, this is the ENA, this is IN1, IN2, IN3, IN4, and ENB. Okay, so now we're gonna start wiring them one by one. So I'm gonna connect the ENA to pin, because ENA wants to change the speed, so I have to choose, a pin that has the PWM capability. So pin number 3 has this capability, so I'm gonna connect the ENA to pin number 3 of my Arduino board. Alright, and now let's just go and connect the ENB. Okay, for the second motor. So ENB goes to, again, I have to choose a pin with the PWM capabilities. So the pin number 5, you can see here, pin number 5 has the PWM capability. So I'm gonna connect it to pin number 5. Okay, sorry, 5 is here. Okay, pin number 5. Okay, and next, now I can just wire my EN pins. So the EN1, okay, so EN1 will go to pin number 8. See, EN1 goes to pin number 8 on my Arduino board. Alright, okay, and EN2 goes to pin number 9. Okay, so EN2 goes to pin number 9, and EN3, so I'm gonna connect the pin EN3 to pin number 10 on my Arduino board, and pin EN4. Okay, let me connect the pin EN4. Alright, so the pin number EN4, so the pin EN4 goes to pin number 11. Okay, so now we can just use our external power supply. So I'm gonna connect it to my to the input of my motor module, motor driver. This is the input for the 12 volts, external power supply. Okay, right, and the middle one is the GND, and the first one, or the third one, is the 5 volts. So I'm gonna connect the middle one. I'm gonna connect it to the negative of my breadboard. Alright, and now the positive, now the 5 volt, or the positive. Okay, so this one goes to the, again, this one goes to positive of my breadboard. Okay, I'm gonna connect it here. Now the negative of my power external power supply, this one should also connect to the GND, so they have all these pins, they have common GND, so this one goes also to the GND of or to negative side of my breadboard. Okay, so that's it. Now we have external, we have DC motors. So as you already know, these two pins, these two, they are the output for my DC motors. So I'm gonna connect, doesn't matter which wire, just connect it. Okay, I'm gonna connect the first motor. Okay, this is the first wire and this is the second wire. Okay, so the first motor connected. Now the second motor, I'm gonna connect the second motor. Okay, I'm gonna connect it like this. Okay, and the last wire. Okay, so the two motors, they are also connected. Okay, so which wire it was? It came out from the GND. Sorry, I forgot to tighten it. Just okay. I'm gonna reconnect the GND of my module or my driver. Okay. All right. So. Okay, guys. Now let's start coding. So, but before we go to start the coding, today, as I told you, we want to see the speed of our DC motors, on a plot. So, in order to do that, we need to just install a new library today. So in order to install your new library, so we're gonna just open our terminal in the Visual Studio Code. Okay, now just be very careful, type down exactly what I type here. So type pip install matplotlib. Okay, so be careful, pip install matplotlib. Okay, now hit enter. So we're gonna wait for the library to install, because I have already installed the library on my system. It shows me that the requirement already satisfied, but for you, if you do not have this library installed on your system, you're gonna see the installation process. It may take a little bit of time. Please just wait until the installation the installation process get complete, and then we can go and start coding. And the first step is to just create a new file. So I'm going to my folder and I'm going to create a new file, and I'm going to call it like soft start.py. Okay, all right. So first of all, we have to import our libraries. So as usual, I'm gonna just import, from pi fermata, import Arduino, and also util, because we want to start iterator. And we're gonna just import time as usual, and we're gonna import the new library that we just installed today. But how we can just import it? I'm gonna say import. So just type down the name of the library. The name was matplotlib, but now, because I want to show the speed on a plot, okay, we want to see it as a plot. So you have to do this. You have to say after you write down the name of your library, just say dot pyplot, okay, as plt. Okay, but maybe you're gonna ask, why do we write import matplotlib.pyplot as plt instead of just simply we could just say import matplotlib, that's all. It's a great question. And I think understanding of this question, it will help you navigate Python's large ecosystem of libraries. Matplotlib is a big library. It's a comprehensive library for creating static, animated, and interactive visualizations. So it contains, many modules, and sub packages. If I can just name some of them, I can say, for example, you can say matplotlib dot, exactly like the same that we said here, pyplot. And the other one, you can say matplotlib.figure or matplotlib.axis or .animation, and many, many, many more. So if you do only, import matplotlib, okay, you only import the top level package. So you would have to access, the plotting functions via, for example, if you want to call only use the pyplot, and if you do not import it like this as here, okay, as plt here, every time you have to write down, for example, matplotlib.pyplot.plot, open and close parentheses, which is, verbose and inconvenient. That's why we just said import matplotlib.pyplot as plt, because it will just make our work much, much easier, later when we want to use this library. Okay, so what is the next step in programming? The next step is to set up our Arduino. So the first step in setting up the Arduino is just defining the port. So I'm using port 9, but you guys make sure that you change it, just change it to your COM port. Now I'm gonna say board. I'm gonna define another variable, and I'm gonna use my Arduino library, Arduino through which port? Through this port. And next I have to just start my iterator, so I'm gonna just create another variable, call it iterator, and I'm gonna use my utility library, util.iterator, open and close parentheses. Where I want to use it in my Arduino board. Now I have to just start my iterator dot start, open and close parentheses, and at the end we're gonna just wait a little bit. Okay, we wait a little bit for the board to initialize. Now we have to the next step, if you can remember, after setting up the Arduino port and after starting the iterator, the next step is to define our pins. Okay, so how we can do that? I'm gonna say we have two motors, and each motor has 3 pins. Okay, so if I want to create variables, I'm gonna say m1, for example, I say motor 1, and I'm gonna say in 1. So motor 1 pin in 1. Okay, this is how I name it. So you can just name whatever you want. It's just a name, it's just a variable name, so it depends completely on you. You can just call whatever you want. So I said m1 in 1, and I'm gonna say board dot get pin, which pin I am using? D. It's digital pin, sorry, pin number 8, and it is the mode is output. Okay, now again m1, but this time in 2. Now I can just easily copy and paste this line. Okay, I'm gonna just copy this line and I'm gonna paste it here, but this time my pin number it's 9, and the last one for the first motor is again m1. So now I'm gonna call it ENA. Okay, so but this time this is the pin number 3, because be very careful guys, because this pin, the ENA pin should be, you have to just use the PWM pin, on your Arduino board. It's very important, otherwise you cannot control the speed. You cannot just have a soft start and stop, and you're gonna have just a constant speed. Okay, so it's very, very important. Be very careful. Now we're gonna just setting the pins for the second motor. I'm gonna say M2, and I'm gonna say in 1. Okay, I'm gonna paste the same line now, but I change it to pin number 10, and I'm gonna say M2 into, okay. Now this time this is the pin number 11, okay, because it's digital and you don't need it. This one doesn't need, the pins for the direction, they don't need to be PWMs. Only the pins that they want to control the speed, I mean the ENA and the ENB should be PWM. So M2, and I'm gonna call it ENB, okay. And this time I'm gonna use pin number 5, okay. So here we configured, the pins for each motor, in1 and in2, are digital output, as you can see here. That set the direction, backward or forward, but we don't need to change the direction today. ENA and ENB, ENA and ENB, they are PWM outputs, but I made a mistake, unfortunately, and fortunately I saw it here, instead of output, these pins, they are PWM, so you cannot just use O, or you have to change the mode to PWM. Be very, very careful, guys, about this. It's very, very important. So just change for ENA and ENB, change the DO to P because they are PWM. So we're gonna run the motors, only forward in this demo, but it depends on you. If you want to use the another direction, you can use. It's up to you. Now, next, we have to define the pins for our buttons. It's because we have two buttons, one button for starting the motors and the second button to stop the motors. Okay, so I'm gonna call it start like button. Okay, it's just again a name, guys. It depends on you. So I'm gonna just name it start BTN, I mean start button. Now I can paste again the same line, but when you change the pin number, be very, very careful. Again, our buttons, they are not output. So the buttons, they are inputs. They're gonna read something and they're gonna just send the data to your board. Okay, so they have to be, you have to change this O to I because they are inputs. And the stop button, okay, stop button, again just change O to I, and the pin number to pin number 4. Okay, now if you can remember, we have to do one more thing here with the buttons. We have to just enable the reporting for our buttons. Okay, so when we set the pins 2 and the pins 2 and 4 as digital inputs, we have to just enable the reporting to tell Fermata to continuously send the state of these pins. It's necessary for reading them in real time. So you have to use the enable reporting to just tell Fermata to just send the state and send the data from this button, from these pins, the pins that these buttons are connected to. Okay, so how we can do that? You can say start button dot start button dot enable reporting, open and close parentheses. Okay, yes, and now for the stop button, I'm gonna say stop btn dot enable reporting, okay, open and close parentheses. Okay, so okay, this is it. So we defined the pins for our motors here, and we defined the pins for our for 2 buttons that we have. So now we finished defining the pins. Now we have to just start setting up the visualization. Okay, instead of now I want to use a matplotlib.pyplot, but as you can see, it's a long name. So instead of just saying typing down like matplotlib.pyplot, okay, I'm gonna just use an alias for this word. okay, because it's too long. So I'm gonna use an alias. It's called PLT. So PLT is our alias for Matplotlib pyplot. Okay, so instead of using Matplotlib pyplot, we're gonna say PLT. Okay, PLT. But by default, when you create a plot, Python pauses the program until you close the plot window. That's not what we want, okay, because we want, we need the plot to update while our loop runs. So what can we do? We can just say dot ion, okay, dot ion, right? plt.ion changes that, it makes the plot non-blocking, so the program continues running and we can update the plot dynamically. So it will change the default system of Python. As I told you, the default system of Python is, when you create a plot, Python pauses the program. So this .ion, it's just makes that make the plot non-blocking. So you can just easily run the program, and while your loop is running, you can just see the data on your plot. Okay, in our plot, we want two axes. Okay, for example, y-axis to see the speed of the second motor, and the x-axis to speed to see the speed of the first motor. And we want a figure. We want a figure to show, the data and everything in that figure. Okay, so let's just define these two. So as I told you, we need a figure, okay, and we need axis. Okay, so we need figure, and because this plt dot and we're gonna say, let me tell you, plt that subplots. Okay, this plt dot subplots, it's a convenient function that creates, both a figure, and one or more axes. It depends on the number of axes that you want. So as I told you, we want figure and axis. These plt dot subplots, it just, very easily, it just creates both figure and function for us. Okay, so this one, as you can see here, it returns two objects, figure, and this fig stands for figure, and this ax, it means the axis. So we will use x, to modify the plot. So one more time, this figure, it lets you to control the whole window, like, the size, the title, etc., everything that's related to the window. And the ax, it lets you to control what's drawn inside of that figure on that window. Okay, now we want to just set a range for our axis. For example, we want our axis to start from 0 to 100. It means we want to see the speed of our motor from 0 to 100. So 0 means 0, and 100 means 1. For example, 1 means full speed. Okay, so we have to tell this to our plot, to our program, to set the range of our both axes, from 0 to 100. How we can do that? Again, I'm gonna use this ax. I'm gonna say ax, okay, dot. So as I told you, we have x and y axis. Okay, so I'm gonna say set x lim. Okay, this is another built-in function in our Matplotlib, pyplot library. These are these greens, these are the built-in functions. Okay, that's a built-in function inside the library. We are just using this library, and these are the functions that are inside of this library. So I'm gonna say x.set xlim. So I want from 0, the first number is the start, and just put a comma, and the second number is, the limit, is the end. Depends how much you want. For example, as I told you, it depends on you if you want to see your speed 0 to 1 or 0 to 500, whatever. I just say 0 to 100, and we're gonna do exactly the same thing for the y axis. So I'm gonna say ax dot set, okay, y lim, okay, set y lim, and again from 0 to 100, okay. So set x lim and set y lim, these two lines, these two lines set the visible range of the x-axis and the y-axis. So we set x-axis from 0 to 100, it means motor 1, speed in percent, 1%, 5%, 10, 20, 50, 200%, and y also from 0 to 100. So motor 2 speed, it shows the motor 2 speed, from 0 to 100. Okay, that's it. But we want to just put some label in our axis. For example, in the x-axis, we want to say this is the speed for first motor, in percent, and in the y-axis we want to say this is the speed for the second motor in percent, and a whole title, like for example we want to say for example dual DC motor, soft start stop control, or whatever you want. So we want to just print some messages, some titles, for our axis. So how we can do that? Again, we can say ax dot, again we're gonna use another built-in function. We're gonna just say set dot x label, okay. So set ax dot set underline x label, okay. What we want to print, for the x label, we're gonna say motor 1 speed, and we want to show in percent. For example, we want to say that these numbers are in percent, so this is the percent sign, okay. Now we're gonna do exactly the same thing for the y-axis. We're gonna say ax dot set y label, okay. Now we're gonna say motor 2, okay, speed, and percent sign, okay. And one more thing, we want to set a title for our figure. So I'm gonna say ax dot set title, okay. For example, like we want to say dual DC motor, like ramp, or we can say start soft start stop, or yes, we can say motor ramp control, okay. So these are these three lines, okay. These three lines, these are self-explanatory, okay. They just add labels to the axis and a title to the plot. Just good labeling makes your visualization much more meaningful, okay. Okay, now here is a little bit the tricky part of our programming, or of our just setting up our visualization. I want to see for example like a point, a circle, or whatever you call it, at the center, for example 0 0, x 0 and y 0, and then when we start the motor, this point start from the 0 0 position, and it will just go. First it will go to the x direction, because the x direction is the first motor, and after the x direction reaches to 100, then it will just continue its movement into the y direction, because the y direction is the second motor, okay. So I'm gonna create another variable. I'm gonna call it point, okay. I'm gonna call it point, right? So point, and I'm gonna use our ax, okay, dot plot, okay. So ax dot plot is used to draw a line or markers, now as I told you, I want to start from a 0 0 position. It means, you know, I want to start from 0 x and 0 y. Okay, how I can do that? Just open and close bracket. So I'm gonna put 1 0. The first 0 is for the x direction, and again open and close, and another 0. So the second 0 is for the y direction. Okay, so it means, you know, a single point at 0 0. Okay, but what color I want, you know, my point is, I want it to be, for example, to be red. Okay, so R means red, and I want it to be, for example, you know, circle marker. Okay, how I can do that? You know, circle marker is like an O. You know, if you can imagine it, it's like an O. So if you just say O here, just don't forget, you know, this quotation mark, guys. So RO. So R stands for red, and O, it means, you know, circle markers. It's completely, again, you know, up to you. You know, the color, the shape, everything. You can just later when you watch this video, you can just change it. You know, you can modify the color and shape, you know, the way that you want. So you don't need to specifically, you know, put RO or put 0 0 here. That's what I just this is my personalization. This is what I want to just my visualization to be look like. So you don't need to do exactly like this, but I am just doing it for myself. Now I want, you know, so as I defined here, O, it means a circle. So you know, a filled circle. But how big I want it to be, I have to just define the size. How I can define the size? I can say marker size. Okay, so marker size, right? So marker size. So I want it to be, for example, like 10. Okay, guys, but this one is also, you know, when we run the program, we will come back, we will see and we check. If it's too big, we will come back and we will just decrease it. And if we see that it's too big, we will come back and increase it. It's just now we want to see the results, so we don't know how it really looks like. So now, for now, I put 10. Okay, and I want to put a label. Okay, I want to give this data series a name, you know, for the legend. Okay, to put a legend. So I'm gonna say how I can do that. I'm gonna say label. Okay, label, and I'm gonna say, don't forget about this quotation mark, guys. So now I'm gonna say motors. Okay, so this is this gives this label equal motors. So it gives the data series a name for the legend. Okay, that's it. But here is a very, very, you know, tricky point, guys. Okay, you know, plot. Let me show you here. You know, plot. Okay, so this plot, it returns a list of line objects. You know, even if you only plot one line, it doesn't matter how many line you plot. It just returns a list of line objects. So we have to, after this point here, okay, so after this point here, you just add, sorry, you just add a comma here, just one more time. So after this point here, you just add a comma here. So what's this comma? You know, by adding this comma after point, you know, we unpack that list. So if you remember, I told you just now, plot returns a list of line objects. So by adding a comma after point, we unpack that list. So, you know, it means the first and the only. The first element is assigned to point. So point now refers directly to the line object we just created. This is common trick, guys. So because, you know, we will later update, you know, its data. So just be careful about this comma, guys. I hope you understand this, but don't worry. If you don't understand this just right now, feel free to let me know. I will explain it in much more details for you later, but now if I want to explain more, the video will be very long. So I think most of you understand this, but if you don't, never ever, just don't worry at all. Just let me know, I will explain more for you. Okay, so at the end, now I just want to create a legend, using the labels we provided. So because here, label here, we just created motor, so I can say ax dot legend, okay, open and close parentheses, right? So this creates a legend using the labels we provided, in this case motors here, okay. So the legend will appear automatically in a sensible location. Okay guys, now we have a plot window with a single red dot at the location of 0 0, 0x 0y 0y. As the motor speeds change, we will update the dots position to reflect the new speeds, creating a live animation of our motor control. That's the visualization setup. It's the foundation for seeing what our motors are doing in real time. Okay, if you can remember guys, I told you, here for today's project we have two states. Okay, when you press the first button, we want to start the motors one by one, and when you press the second button or the stop button, we want to stop the motors again one by one. So now we can define two different kind of functions here. So the first function, I'm gonna say def, so I'm gonna call it like set motor. Okay. So I'm gonna just we have 4 arguments. We can define 4 arguments here, okay, because we have 4 pins. We have we have a motor en, we have a motor in1, in2, and we also want to control the speed. Okay, so I'm gonna give my function 4 variables. Okay, so I'm gonna the first variable is motor en. Okay, motor en. Okay, the second variable is motor in1. Okay, the third variable is motor in2, and the fourth variable is the speed. Okay. Okay, so here in this function, first of all, I want to just start when I press the start button, I want my motor to spin in forward direction. Okay, so we don't have any backward direction in this program, only one direction. So I'm gonna call motor en1, okay, dot motor en1, okay, dot right. We made a mistake here. So here we just motor, yeah, it's okay, motor en1, yeah, motor en1, that's right. So I want to turn it on, and I want to turn the other direction off. So I'm gonna say motor en2 dot right 0. Okay. Now about my speed control. Okay, because the pi formata, PWM expect to receive something from 0.0 to 1.0, but now, as we saw here, as I told you above, so we want to see from 0 to 100. So in order to just tell this to our program, we have to divide everything to 100. Okay, in order to just to scale everything to 0 to 1 to the PWM pin. Okay, so for the speed, I'm gonna call motor en, okay, dot right. So here I want to divide, as I told you, to divide the speed by 100, okay? Because I have to scale everything to, because I have to scale, to 0 to 1. So I have to scale from 0 to 1. So how I can do that? I'm gonna say speed, okay, divided by 100, just 100. You don't need to just say, you can just say 100 or 100 because it's a float. If I do so, this function takes a motor's enable pin and two direction pins and a speed percentage, because if you can see here, the speed was in percentage, okay? So the speed percentage, I mean 0 to 100, and it sets the direction to forward, I mean en1 goes high and en2 goes low. Here, 1 means high, 0 means low, and it writes the speed scaled, to 1 to 0 to 1, to the PWM pin, because we divided the speed by 100, okay? And it doesn't matter, you can just put 100 here, you don't need to say 100.0. So that's it. That's for starting the motor. One more function we have to create one more function, and that function for stopping the motor, okay? So I'm gonna call def stop motor, okay? And now this time I have to give it 3 arguments, okay? Stops because we want to stop the motor by disabling PWM and setting both direction pins low, okay? So I'm gonna say motor en, okay, and one more motor in 1 and motor in 2, okay? So these 3 arguments, and I want to put everything low. How I can do that? I can say motor en dot write 0 and motor en1 dot write again 0 and motor en2 dot write 0 again. So it stops the motor by disabling PWM and setting both direction pins low. And alternatively, you could set both high for braking if you have any brakes, if you want to define brake in your program. But for now, to keep everything simple, I just put them low. So that's it. So we defined 2 functions, and now we can go to the next step. So the next step is we have to just define our initial states, okay? So at the beginning, both motors, both motors, they are off. The speed is 0. So I can say motor 1 speed 0 and motor 2 speed also 0. Okay. The next thing, I want to just tell my program, how much speed should change, each time that my loop, the main loop, just, repeat. Okay, so I'm gonna call it like a ramp step. I want, 2%, okay? So it means that, ramp step is how much speed changes for each loop. So I said 2%, but again, it's just it depends on you. You can change this number to whatever you want. The next thing, I want to say the running. Okay, I'm gonna call it a running, but what is this running that at the beginning I say at false? This running is a boolean that indicates whether we are in ramp up or ramp down mode. So at the beginning, we are not in any of their modes. So I said false. And we have 2 buttons. So we have to just, our program should know, about the previous, state of our button. So I'm going to call it prev like start. Okay, so at the beginning it's again this one also false, and for the stop button, prev stop, this one also false. So this prev start and prev stop, they store previous button states to detect rising edge, I mean when a button is first pressed. So at the beginning both of them are false. Okay, and I also want to print a message, when we run the program. I want to print a message for the user, for the operator, or for whoever just working with this system. And I want to tell them that, for example, like system ready. Okay, and I'm gonna say press start to run motors. Okay, this is the message. Okay, and so far we just defined the pins, our visualizations, and the initial state, and it's time to just define our main loop. Okay, so I'm gonna just start my main loop as usual with the try block, because later we want to define the except, because we need to define the emergency shutdown for our program. So I'm gonna say try and I'm gonna say while true is true. Okay, now the first step in our main loop, I want to check the to read my buttons. Okay, to check the states of my buttons to see if the start or stop, one of them is pressed. Okay, so how I can do that? I'm going to define two different variables. I'm going to call the first variable like start pressed. Okay, so now I'm going to call my button here that I defined. See, start button and stop button. Okay, so I'm gonna say start button dot read. Just be very careful. Why dot read? Because these two buttons, they are input. That's why I have to say dot read. Okay, but there's a problem here, guys. In Python, when you read a digital input pin, using this dot read, okay, it can returns a few different things. So it can returns a true or one if the pin is high. I mean, if you press the key in a wiring, or it can return false or zero if the pin is low. It means the button has not pressed. And it can just return none if the iterator hasn't yet received an update for that pin. Okay, so the value could be a boolean, an integer, or none. Okay, in our program we want start pressed. Okay, this start pressed to be a value we can use in logical conditions that we're gonna define later, because after we define these start and stop pressed variables, we need to just define some if conditions. Okay, and we want to use these variables in those if conditions that we're gonna define later. So what can we do here? Now we can use a trick here. Here you can say or false. Okay, it may just seem a little bit odd for you now. Okay, but why the solution is or false? So the solution, I said there's one, we can use this or false. Okay, this expression, the start button dot read or false, it works like this. If start button dot read, this section, if this section it returns a truthy value like true, one, or any non-zero number, the whole expression evaluates to that truthy value. If I want to give you an example, I can say in Python, x or y returns x if x is truthy, otherwise it will be y. okay? And if start button dot read this section, it returns if this part if it returns a falsy value like false, 0, or a none. So the expression evaluates to false, okay? It's I mean it goes to the second operator, right? Because we use or here. So this this using this expression start button read or false, this guarantees that the start pressed will always be either a truthy value, I mean when the button is pressed, or false when it's not pressed or not yet known. I mean, for example, if our iterator hasn't started yet. So it effectively converts any non-truthy result to a clean false. There's also an alternative way if you don't want to use this or false here. For example, in your coding you can say like bool and you could say start button, okay, start button, yes, dot read, open and close parentheses. So you can, instead of or false, you can use this expression bool start button dot read. But the or false, this or false idiom is slightly shorter and very common, in Python meta examples. So I just tell you this because I wanted you to know that you don't have only to use this way. You can also use this way, but I prefer this way because it's more common, in Python meta, examples and other programs. Okay. So if I want to give you a summary of this, or false, why we use or false, using or false, when reading Python meta pins in a safe way to ensure that your variable always holds a usable, Boolean-like value, never none. It protects against, the initial period when the iterator hasn't yet, delivered data. And it simplifies, later logic by providing a consistent false or not pressed conditions. So now we're gonna do exactly the same thing for stop button. For I'm gonna call this variable like stop pressed. Okay, so I'm gonna say stop button dot read, open and close parentheses, and I'm going to say again or false. So now we know that why we're using or false. Okay, so here we read each button. That the or false ensures that if the read returns none, example, no data yet, so we treat it as false. Okay, now we can go and create our if conditions. Okay, now I want to just press the button, the start or stop button, and then leave the button, and the program just do the rest. I mean, I don't want to hold down the start button until the motor ramps up, and the second motor also the same. I want just press the button one time, and the motor start from 0, I mean from soft start to full load, and exactly the same thing for stop position for stop state. So for now, to do that, if you can see here, we defined this in the initialize state. We defined a variable, we called it running, and at the beginning we just we made it like as a false. Okay, so now I'm gonna use an if statement. I'm gonna say if, okay, sorry, okay, so I'm gonna say if start press and not previous start. Okay, so but what does it mean? As I told you, we need to detect the moment the button transitions from not pressed to pressed. Okay, that's called a rising edge. To do that, we remember, the previous state of the button and compare it, with the current state. So this previous start, it stores, whether the button was pressed in previous loop iteration, and this start pressed, this is the current state. Okay. So this condition, if start pressed and not previous start, is true. Only when the button is currently pressed. I mean, start pressed is true. Okay, this one, and it was not pressed in the previous iteration with this one. Not previous start. Okay, that's exactly the rising edge. So the first moment the button becomes pressed. Okay. Now, so if this is true, then what's gonna happen? Now we're gonna just update our running variable. So at the beginning it was false, but if these two condition, if these two, they will be true, then we're gonna update our running variable, and we're gonna just make it true now. And for example, we can print a message for the users. We can say start pressed. Okay, and we can say motors ramping up. So this is this is for the start button, and we're gonna do exactly the same thing for the stop button. So I'm gonna say if stop button, if stop pressed and not previous stop. Okay, so I'm gonna say again, now this time we're gonna just call this running exactly the same that it is. So I'm gonna say running equal to false. Okay, now we can just print again another message. We can say stop pressed. Okay, let me just do it the same. So P in capital to make it the same like this message. Okay, now I'm gonna say motors ramping down. Okay. Okay, now if you can see here, the previous start, okay, the previous start and the previous stop. So now we can update both of these variables here at the at the end of this two if condition. So I'm gonna update them. I'm gonna say previous start. Okay, I'm gonna just call this I'm gonna just stop this use these two variables that I defined here. So I say previous start equal to start pressed, and previous stop also equal to stop pressed. Okay, so this is for these two if conditions. So just one more time, by updating these two variables here, these sets the stage for the next loop. Now in subsequent iterations, while the button is still held, start pressed. Okay, this start pressed will still be true, but the previous start, okay, the previous start will also be true, because we just said it. See, the previous start equal to start pressed. Okay, so the condition start pressed and not previous, this one, start pressed and not previous start, becomes false. No further toggles occur until the button is released and pressed again. Okay, after just toggling our buttons, now it's time to just define our automatic ramp logic. Okay, so how I can do that? I can just start with an if condition. I can say when this running is true. So I can say if running I just say if running because and I don't say if running is true, because when I say if running, it's automatically the Python detects that if running means if running is true. So now I want to just say, if the speed of my first motor is less than 100, because I said, the speed start from we assume that our speed is from 0 to 100. Now I'm gonna say if motor 1 speed is less than 100, because as I told you, I want to start my first motor at the beginning, then after it reaches to the full speed, then the second motor will start running. So if motor 1 speed less than 100, then what's gonna happen? Then motor 1 speed, I want to, if you can see here, we just defined a variable in initializing state. So I'm gonna say motor 1 speed, I want to increase it, but how much I want to increase it? Plus equal to ramp step. Okay, and I'm gonna say if now I want to clamp the speed to 100. So I'm gonna say if motor 1 speed greater than 100. Okay, so I will just clamp it motor 1 speed equal to 100. Now I'm gonna call my this set motor function. I'm gonna call my because this is for running or stopping the motors, and this one we defined it for our emergency. In our emergency button, we're gonna call this function, and in our soft start or stop state, we're gonna use this function. So I'm gonna call it. I'm gonna say set motor. But here, just take a look, guys. Be careful here. We passed it, 4 arguments. Now here you have to pass it exactly these the 4 arguments, but just be careful. The first, the second, the third, and the fourth, they have to be exactly like here. So the first one was for the ENA pin, if I can remember. Yes, CEN, IN1, IN2, and speed. Okay, so I'm gonna say M1 ENA, and the next one is M1 in1, and the M2 in2, and the last one is the motor speed, motor 1 speed, motor 1 speed. Okay, so this is for the first motor. Now I want to say after the first motor reaches to the full speed, now go to the second motor. I'm gonna say elif motor 2 speed. Okay, if again exactly I'm gonna do the same thing, but instead of the first motor, I'm gonna use the second motor. So if elif motor 2 speed less than 100, then what's gonna happen? Motor 2 speed, okay, plus equal to ramp step, right? And I'm gonna say if if motor 2 speed, okay, less than 100, I mean greater than 100, because I want to clamp it, motor 2 speed equal to 100. Now again I'm gonna call my set motor function, set motor, but this time be careful, I'm gonna use M2 ENB, yes, M2 EN1, M2 EN2, and the last one is motor 2 speed. Okay. So here what did I do here? When I said when ramping is when running is true, sorry, see, when running is true, we ramp up. Notice just the order. I said first motor 1 increase to 100%, then motor 2. This sequential ramp is just for demonstration. You could just modify it to ramp simultaneously, but if I want to tell you why I did that, because in real projects, in big projects, they're gonna do the same thing, because the big motors, they're gonna just they take so much of currents when they want to run at the beginning. So because they want to decrease using of the currents, they just try to start them one by one. So this is exactly what they do in real projects. Now let's just define. So this was for soft start. Now let's just define a soft stop. So it was soft start, and now we have to define soft stop. So here we said if running, because we only have one start and stop, we can use if else. So here we said if running is true. Now I can use else here. So what else means? Else means when running is false, then what gonna happen? I'm gonna start with the second motor now. I'm gonna say if motor 2 speed greater than 0. Okay, now motor, because I want to decrease from the speed, that's why motor 2 speed minus equal to ramp step. Okay, and now I want to clamp it to 0 if motor 2 speed less than 0. Okay, what I'm gonna do, I'm gonna just clamp it motor 2 speed equal to 0, and I'm gonna call the again this function, the set motor function, set motor. And but be careful, guys, I don't want to just type it down again, just copy and paste this because it's exactly the same thing. So instead of typing it, I'm just copying and paste it, set motor M2. Yes, and after the motor 2 is just ramped down, now I want to do the same thing for the first motor. I'm gonna say elif motor 1 speed, okay, greater than 0. Then what gonna happen? Motor 1 speed, okay, minus equal to a ramp step, right? And now I'm gonna say if motor 1 speed, yes, now let's clamp it, it's less than 0. Okay, now motor 1 speed equal to 0, and again I'm gonna call exactly the same set motor function for the first motor. Okay, all right, so so I said here I said when running is false, we ramp down in reverse order, motor 2 first, then motor 1. This creates a nice symmetry effect, right? Okay, guys, so now we finished here. Okay, we defined everything. Just before we just go and create our except block. Okay, if you can remember here, we just we created in our code we created, okay, here we created this point. Okay, we created a plot with a single red dot, but I have to update it. I want it to move when my model is just ramping down or sorry, ramping up or ramping down. I want to update the position of that point. Okay, so how I can do that? I'm gonna just here I'm just coming here. Okay, I'm gonna use that point that I created earlier, as I showed you just now, point dot. Now I want to use another built-in function. Okay, it's called set data. Okay, set data. So set data is a built-in function. Okay, this set data, this is it's a method that used to change the data that the line display. And it expects two arguments. One for x coordinates and one for y coordinates. So what is our x coordinate? Our x coordinate, if you can remember, it was our motor 1 speed. Okay, so I'm gonna just give it motor 1 speed, and for the y coordinate I'm gonna give it motor 2 speed. Okay, but notice that we pass these values, these two coordinates uh, inside the square brackets, mother 1 speed and mother 2 speed. Why we did that? Because set data expect sequence like list or arrays, even if we have only one point, but you have to pass it like an array. So if we passed single numbers, it would raise an error. So we wrap each speed in list to create a sequence of length 1. But there's a problem. Matplotlib separates the data from its visual representation. Changing the data with set data with this built-in function only modifies the model. To see the change, we need to tell figure to draw itself. How we can do that? I'm going to use another method here. You can say fig.canvas.draw. Okay. Again, this dot draw is a built-in function. This fig.canvas.draw is exactly the thing that I told you earlier, to see, because we have to just redraw the canvas. It refreshes the entire canvas and rendering all the lines, axes, labels, etc., whatever you have in that window with a new data. So if you want to keep your canvas, if you want to keep your figure update, you have to use this fig.canvas.draw. Now we need one more thing here. Okay, when you're in interactive mode, I mean this plt.in. Let me show you this plt.in. When you are in this mode, okay, the plot window, the plot window runs its own event loop to handle, things like mouse clicks, a window, resizing, and repaints. So after we call, this, and after we call this dot draw, we need to give the GUI a chance to actually process the drawing commands and update the window. If we want to do that, we have to use fig.canvas.flash events, open and close parentheses. Okay, flash underline events. Yes. Oh, just made a mistake. 2 dots here. Okay. Again, we use this built-in function dot flash events. Okay. So it tells the backend to process any pending GUI events immediately. So without this line, the plot might not update until the script ends, or the next time the GUI loop runs, which could be too slow for smooth animation. So if you want to have a smooth animation, you have to use this built-in function, I mean this dot flash events, and you have to use this dot draw to just as I told you, to redraw the canvas. Okay, but just one more time, why do we need all these three set data, draw, and flash events? Set data, it updates the underlying data. As you can see, we pass it two arguments, x coordinates and y coordinates. Draw, it re-renders the plot with the new data, and flash events ensure the window shows the update plot immediately. Without any of them, you wouldn't see the dot move. Okay, so the only thing that now we have to define here. Okay, now I want to just define a little bit sleep time. I'm gonna say time that sleep. For example, I'm gonna say 0.005, but it depends on you. But what is this time that sleep, not time that time? Exactly, the same mistake that I did before. It's gonna just show us an error. So time that sleep. This short delay controls the ramp speed, because each iteration changes the speed by 2%, because we defined this here by our ramp step. Okay, So it changes the speed by 2%, you know, but for how long? Each 0.05 seconds. So it means, you know, a full ramp from 0 to 100 takes about, you know, like if I want to calculate, I can say, you know, 100. If I want to show you, I can say 100 divided by 2, okay, times this time that we define here, 0.05, okay, and it will give us like let's calculate this. It will give us almost about so I said 100 divided by 2, okay, 50 times 0.05, okay, 2.5 second, guys. So it means, you know, a full ramp from 0 to 100 takes about 2.5 seconds, okay. This is what so you can change this time, you know, according to the time that you want. It's completely up to you. So this is this time, as I told you, it controls the ramp speed. So for each because for each iteration, one more time, for each iteration, the speed changes by 2% every 0.05 second. That means, you know, it takes 2.5 seconds for motor to reach from 0 to 100. Okay, so now we finish here. The only thing that we have to just define, you know, I want to say if you press Ctrl C or emergency button, we stop both, you know, motors. We want to close the Arduino connection and print a message. How I can do that? I'm gonna use except block, except keyboard interrupt. Okay, I'm gonna, now it's time to use my stop motor, you know, function. I'm gonna say stop motor. Now if you can remember, it had 3, you know, arguments. I'm gonna say M2 ENA, M2 M1, why is it M2 M1 ENA, M1 ENA, okay, M1 EN1 and M1 EN2, okay. Now I'm gonna do exactly the same thing for the second motor. So I'm gonna copy and paste it, but instead of M1, I'm gonna say M2, M2 and M2 here. Now I just, as usual, I'm gonna say board dot exit, open and close parentheses, and I'm gonna just print a message at the end for the user. I'm gonna say program terminated safely. Okay, so yeah, this is so far I don't think that anything else left. Today's code is very long. Okay, now it's time to just run our program and see if everything works okay. Okay, now let's run the program and see the result. As you can see here, you know, these are my two DC motors. Okay, now I'm going to press a run button and we're gonna see what happen. Okay, so waiting. Okay. It may just, because the program is a little bit, you know, long, it may take a little bit time for it to, okay, see, now our figure is open, and as you can see, this is our dot, you know, 0 0 0 x 0 y and 0 y, and the x-axis is the motor 1 speed and the y-axis is motor 2 speed, and you know, here you can see the title, dual DC motor ramp control, and this is the motors, you know, the legend. So now I'm going to press the start button. Okay, so I press and leave it. Okay, see, so this motor now it starts ramping up. Yeah, and if you can see here, see, So the now 80%, almost 90, and 100. Okay, now the second motor. Okay, everything works perfect. Yes, and this is the second motor. And just check. Here you can just see now 60%, almost 70, 80, 90, and 100%. See? So now both motors, they are just, and see the console, it says, start pressed and motor ramping up. And now I'm going to just press the stop button. Okay. Okay. So see, the motor number 2 is ramping down. Just check. This is the motor 2. Okay, now it's almost 40%. Yes, it's great. It's working perfectly. Okay. Yes, the motor 1 stopped, and the motor 2, and now the motor 1 is ramping down 80%, 60, 40. Okay, it works perfectly. Okay, now it stopped. Now let's just try one more time. Let me just press the start button. Okay, and check this. Okay, so yeah, so the motor is starting soft, soft start. Okay, 60, almost 70, 80, 90, and 100%. Now the second motor. So yes, it's starting. Okay, it's great, guys. Everything works perfectly. Now just let me press Ctrl C and see if our emergency button works, correctly. Oh, okay. See, now we have a problem here because okay, it says let's just check in our stop. Okay, yes, sorry, I made a mistake here, because I just copy and paste everything. I made a mistake here. So here you should just, instead of M2ENA, for the M model 2ENB we should use. Yes, this one. Okay, now let's just try one more time. Okay, we're gonna run the program. Okay, we're waiting. Right. Okay. Okay, now I have, let's press the start button. Okay, the first motor is ramping up. Yes, see? So this is the first motor. And now it's almost 50, now 60, and now 80, almost 90, and now 100. And now this is the second motor. It will, yes, and now it started. Now let's just try the Control C button to see if our emergency button work now. Let's let's wait for the both motor to reach 100. Okay, now let me press Control C. Okay, see, everything just stopped and program terminated safely, and we exit from the program. Okay, hope you just like this lesson. It was a little bit, advanced because we had so many codes. Okay, I hope you like this lesson. If you have any question or if you have any doubt, please let me know. See you in the next lesson.